Hello, welcome once again to physics class. In today's class, we are going to continue with radioactivity. Okay, we have question from it, and this is number 2 question that I am going to solve on this topic. So let's look at the question. The question says, a sample of radioactive substance was found to be left with 1/32 of its original count rate after 110 years. Calculate its decay constant. So this question is not going to be straightforward. Good. But before we solve that, if today is your first time of coming across my video on this platform, please follow me. You're going to benefit so much. As far as mathematics and physics, chemistry is concerned, you're going to be enjoying my teachings. I don't rush to teach students. I always make sure that I capture the lowest learner in the class. So if you do so, God will bless you. And also help us to share. Now, we want to look at the decay constant. The formula for decay constant, let's go. Is this what? Lambda equal to 0.693 all over the half-life. Good. So this is the formula we are going to be using to calculate the decay constant. But now, we don't have the half-life from here. So that is why physics is very, very difficult. But to some students that know what they are doing, it's very easy for them. Good. Because physics is not just something you just apply formula and you get it straight. No, you must first of all derive one before you can be able to get the next parameter you're looking for. Unlike mathematics, that you just apply the formula and straightforward substitute and you get your values. But now we first of all have to look for this half-life. And this half-life has so many things to come across before we can get it. Now look at this formula that I always use. This formula says NR equal to N naught all over 2 raised to power N. But this one does not have anything to do with this half-life, which is T. So that will not take you to this N. It is this N here that has a relationship with this half-life. Remember, there is N here. This N here is equal to small letter t all over what? The half-life. That is what? Small letter t all over the capital letter T. And this capital letter T represents the half-life. So which is this what? Small t all over what? This. So once we are able to get this our N, then we get our half-life, then we come back here and plug it into this equation. Into this formula, then we get our answer. Now remember the question, look at it. Say, well, a sample of radioactive substance was found to be left with 1/32 of its original what? Count rate. It means that the mass is now being reduced after it has decayed. It has been reduced by what? 32. Meaning that what? 1/32 is multiplying the original what? Mass. So we are going to look at this. This NR here represents the number of the mass remaining. So which means NR now, according to the question, says well, a reduction, it was 32, 1/32 of means for multiplication. So let's just put what? N naught. This is what? Original mass. So here, the N naught, we don't know. Small letter t is equal to 110 years. Let's come back to this formula here. So that we have NR equal to what? N naught all over 2 raised to power N. Now we want to multiply. We want to multiply this. We're going to have 2 raised to power N multiplying NR equal to what? N naught. So that at the end of the day, we're going to have 2 raised to power N. I'm going to divide this. It's going to give me what? N naught all over what? NR. Now let us substitute now for this NR, which is what? The remaining. Look at it here. So this is sitting as saying N naught all over what? 32. So let us plug it here. If we plug that into that expression, we're going to be having 2 raised to power N equal to N naught all over, because here becomes what? N naught over what? 32. So which is the same thing as saying N naught over 1 Remember, n naught over 1 times 32 all over what? N naught. So when you transform this, I skipped one step. Okay. So when you transform this, this is what they are going to have. So this n naught here we cancel out. So that we have 2 raised to power n equal to what? 32. Okay, that's 32. Now we can express this 32 to become 2 raised to power 5. Good. So let us express it that way so that we can be able to cancel out the base. We want to express this one to base 2. Okay. So that we have 2 raised to power n equal to 2 raised to power what? 5. Then this one and this one can go. Your n is equal to what? 5. Good. Now let us take this n. Let us take it to this equation, which is this formula here, so that we can be able to calculate the half-life of what chemical reaction, this radioactive reaction. N equal to small t all over what? The half-life. So this will now imply that what? N is 5 equal to 110. Remember, the time it takes to decay is 110 all over what? The half-life. Now, if you cross multiply, when you cross multiply, you are going to be having t after cross multiplication and making t is all your formula. I'm going to have 110 all over what? 5. So your t is equal to 22 years. This is 22 years. So let us go back to this our original equation. So this is what we want to find now. So we're going to give you lambda equal to 0.693 all over our 22. So get your calculator, let us divide it and get our answer. So at the end of the day, you're going to have 0.0315. 0.0315. Now, because we are dividing by year, it's going to give us a per year. So this is the answer to this question. So you can see physics is very easy once you understand basic concept and also learn how to apply formulas. So all the formulas in physics must be in stock. So don't ever forget any of them because they are very, very useful. If you find this class very interesting, please help us to like, follow, and also share this post so that it can get to greater number of people across this platform. To do so, God will bless you. Bye.